Okay, so this is the new version of the calculator that I've been working on, and I'm gonna give you an update. There's been a lot of changes. I added a couple of functions. The backspace button, floating point input, positive negative switch, fixed a few bugs, and I'm gonna, I guess, go through all the code again. I'm gonna just like glance over the old code and go over the new code in greater detail, so stick around and let's go. Well, first of all, I added another row of the buttons on top of the existing ones. This is the backspace button, the floating point, positive negative switch, and this is the it's supposed to be repeated / iterative calculation switch. So in the future, when it's engaged, if you hit the equals button multiple times, it's going to iterate on the latest operation. If it's disengaged, it's not going to do anything. You hit equals and the result will stay the same. It's not going to be iterating. This was pretty easy to do. I just did something like that, add row above, and it automatically offset all the indexes of the existing rows. Now I had to copy and paste the latest row, just change the IDs and stuff, and assign the on-click functions. So this is pretty simple. Let's go to the main class, which is the controller. I mean the main because most of the code is here. So again, I'll go over the defined global variables. Actually, let me go ahead and just like do a little demo of the calculator. Not gonna be clicking with the mouse. I'm gonna just tell you what I do, because you can't really tell. So let's, for example, input a number and make it negative. The F10 button is the hotkey, and then you can plus 1, and then you can iterate by hitting the result button, just like that. This the result value is it's immutable, and it's by design, because I modeled this calculator like after Windows standard calculator on Windows 11, and you cannot modify the result there, and I figured I'd do the same for this calculator. I believe on the iPhone it's the same, so when you start inputting, like when you hit any digit, it will start inputting the first operand of the next operation. So if I hit multiply by 2, this is going to be the result. You cannot change it, although I think you can make it negative, but I guess I need to fix that. So you iterate, you clear. Let me show you the floating point input. So if you just hit floating point, there's 0, and you hit floating point, it's gonna append it to 0. Then you can start inputting other digits. If I multiply this by 2, it all works. Can make it negative, whatever. let me show you the backspace button. Just with a regular positive number. Works just like that. With the negative number, works properly. Floating point, decimal, and you can edit the number. You can append digits after backspacing. So if you need to change that, you can. Even to this point, it's all good. Hit backspace again, 0. Negative numbers. Negative floating point numbers, which was a little tricky to do. So you can edit it to this point, append different digits, and then when you hit the backspace again, it will not only remove the point but also the minus sign. And if, for example, you input, you don't finish inputting like the digit, it's all good. When you hit the operator button, for example, minus, it will reset, it will clear all the trailing zeros and the floating point. It's the same if you backspace, it's all code embedded in code. For example, if you backspace to this point and you hit any operator, it will clear. Same thing if you do this, it will also clear as soon as you hit the operator button. So that's it with the demo, and let's go over the code real quick. This is all the same. Global variable string flag stores the operator so that the equals on-click function knows which operation to perform. There are if conditions, plus, minus, multiply, and so on. This stores the first operand, num1. This stores the second one. This num iterative, I'm gonna be just reading the comments. Stores the latest operand to be used as the second operand during iterative calculation, and it's also used in a couple of checks. After the operator, this flag lets the on-click functions of the number buttons know that an operator button has been pressed, and they need to replace the displayed number entirely instead of appending digits to it. This flag equals, I'm not sure why I'm setting this to false. I think something gave me an error, like it was null or something, but shouldn't Java initiate it to false by default? I don't know. Maybe I'll fix it later. This flag lets the on-click functions of the number buttons know that the equals button has been pressed and they need to replace the displayed number entirely instead of appending digits to it. Pretty much the same as this one. Okay, the digit buttons, we'll just go over the first one. So this if statement checks if the 0 without the floating point is being displayed, or either an operator button or equals button being previously pressed. If this condition evaluates to true, this line resets the displayed number to the button's digit, so it basically overrides the whatever number that's on the display. Sets the operator flag to false, after the operator flag to false after the first press to allow for appending digits. Sets the equals flag to false after the first press to allow for appending digits as well. Else, if this doesn't evaluate to true, there's no floating point or a 0, it will just append the digit 1 to whatever that's on display. It will get the number that's already on the display. It will append its value to it, meaning 1, and then it will display the resulting number. It's all the same for other digit buttons, 2 through 0. Yep. And then this C button clears the display, resets all flags, empties all variables. So we have a clean slate. This is the first of the operator buttons, the addition. Each operator button functions exactly the same, except the operation itself is different. Just in case the user has backspace to -0 point after entering the first operand, we perform the steps below. We preset the format of the string. No, it's not of the string, it's of double. Yeah, whatever. This converts double to string and formats it, stripping any trailing zeros and the floating point from the number displayed. Because when we hit the operator button, it's this. I showed you this before. For example, we have this, and we backspace to this, or to this, and we hit, for example, divide. It strips the floating point and the minus because there's no point in those values. Then it checks if the resulting trimmed value turned out to be -0 without the floating point. If it values the true, if it's -0, it strips the leading 0 from the 0. I'm sorry, the leading minus from the 0. And then it does it outputs the corrected value to the display, the cleared value. Then it's all the regular stuff. Stores the current display number in the global variable num1. Sets the operator flag to the corresponding operator sign. This lets the digit buttons know that they have to overwrite the number displayed. It sets the flag to true after the operator. This empties num iterative so that the function calculating the result knows that the next iteration will be the first and to use num2 variable as the second operand instead of num iterative. This is very important because when we do this calculation, for example, we do the first operation is 1 plus 2. So 2 is the second operand in the on the first iteration, right? And we need to remember the second operand to use this as the second in the next one. This equals to 3, and then if we hit, remember we don't input in this case the second operand manually, it's remembered in the memory in num iterative. So if we just hit on this result, we hit equals again, it will perform the operation 3 plus 2. So it will take the result as the first operand, and it will be equal to 5. It's all the same with all the other operator buttons. Now the most verbose section is the equals button on click function. Calculates the resulting value. So this if checks what the operator flag is set to. In this case it's plus. If num iterative is not empty, that means the second operand from the previous operation was stored in, I should just say has been stored in num iterative and will be used again as the second operand here. This stores the outputted result of the previous operation in num1. converts the values of both variables to double and stores the result, converts the result to string, presets the format, converts the string result to double, formats it and outputs it to the display, sets the equals flag to true. This lets the digit buttons know to overwrite a number displayed on the first press. So this is in case of like the second iteration, and in case the first iteration. If num iterative is empty, that means that this is the first iteration of the operation. Checks an empty string. Stores the value of the second operand currently on the display into num2, because we entered it manually. Converts the values of both variables to double and stores the result. Converts the result to string. Presets the format. Converts the string result to double, formats and outputs to the display. Sets the equals flag to true. You know what it does already. Now, this stores the second operand into num-iterative to be used as the second operand during the second and all consecutive iterations. So it's important to remember num2, what was in num2, and store it into num-iterative. And this empties num2. Yep, I guess this was the most difficult section. And in case of all the other operators, it's all the same. Check if it's iterative or not, if it's the first or the second iteration, sorry. This repeat switch, what it's supposed to be doing, I already explained. It's to enable or disable, toggle on and off iterative calculation. I haven't implemented it yet. The negative button switch function. Switching to negative or positive number, depending on what's already on the display. So, grabs the displayed value, converts it to double, and stores it in displayed. Now it checks if the number is negative, converts to positive and stores it in displayed pause. This is done through math.absolute. What is it called? Method? I guess it's a method. Library, I don't know what it's called. Presets the output format, and then it trims the final value, converting it to string, and outputs to the display. This is done basically, I think I already mentioned, to strip the trailing zeros, for example. If the number is positive, convert to negative and store it in display neg. This is just like done in this way, real simple. Just append the minus sign before the variable. It will convert to negative. Same thing, presets the format, trims the value and outputs to the display. Pretty simple stuff. Introducing the floating point into the input. So it stores the currently displayed text into displayed variable of type string. If there is no floating point already and none of the flags is set to true, append the floating point to the currently displayed number and output the resulting value. If either of the flags is set to true, then I'd like the app to input 0 point for the first operand or the second operand. For us, if we hit the floating point button after either seeing the result or pressing an operator button. This is just done for convenience, so we don't have to like do it manually, right? Then it sets display text to 0 point for us, resets both flags. So if we input the first operand, maybe it's the floating point, like the fractional number already, right? We want to input the second number. We hit an operator button, for example, plus, and then we know that the second operand will be 0 point something. We can just hit the floating point and it will input 0 point for us. We don't have to input 0. And we can continue. And this is the backspace button function, deleting the last digit on the display. This makes the backspace only work on entered operands, not the result, because we don't want to edit the result. I explained that it was the intended behavior. Grab the displayed value, store in displayed. If there's just a character on the screen, just a single character, set the displayed string to 0. Now, if there's more than one character, we reduce the length by 1, the length of the string, and output the resulting value. If there's either a single character with the leading minus or a 0 with the leading minus and the decimal point, then we set the displayed string to 0. It's just to prevent like this bugs, so that we end up with like -0. So for example, the last if statement condition makes sure that this behaves properly. We edit it to this point, and then when we hit the backspace again, we don't end up with -0. It will just set it to 0. So this is how it works. This is how it works. I guess that's it. Oh, okay. Let me go over the hotkeys just quickly. Again, to access the buttons from the fxml, I have to do this. Have to initialize these variables. Button 0, button scene.lookup, and we input the ID of the button from the fxml file. fxid are these ones. So we define those, access the buttons in the fxml file. Then we have this event handler that detects the keys that are being pressed. We switch. I made this like switch statement for most of the buttons. If either the 0 key on the number row or the numpad 0 is pressed, press 0, the 0 button programmatically. So row number, numpad, and then key consume is important. I'm not sure exactly how, like, I've read a few explanations how it works. It destroys the event, so it doesn't trigger anything else. And yeah, at one point I didn't have this and there was some bug. I don't remember which one, but it behaved weirdly under certain circumstances. It's all the same for a lot of buttons, but for this number row key, we need to trigger an event with both shift pressed and shift release, so I included it from the switch statement and wrote to if conditions instead. So if shift is pressed and the key code is equals, this is the equals /+ button on the number row. So with the shift down, it's a plus button, so we perform the addition operation. If the shift is released, it's not down. Then we perform the equals, we calculate the result. And the same is on enter, regardless of if the shift is pressed or not. This is the OR condition. Same thing for the digit 8 on the number row. If you don't hold the shift, it should be 8, should input 8. If you hold shift, then it will perform multiply. It's the multiply operator. Okay, I hope this made sense, and I'll see you in the next video.